You're looking at a circle divided into three pieces. Two of the pieces are green and one of the pieces is yellow. And the yellow piece represents 1/3 of the circle as shown at the bottom. The 1 is the numerator and the 3 is the denominator of what is known as a simple fraction. Now we divide our circle into 6 pieces, but the yellow region is unchanged. Now it's 2 pieces, 2 out of 6. I hope that makes it clear that 1/3 is equal to 2/6. Now we divide it into 12 pieces. 4 of the 12 are yellow, so 4/12 is equal to 2/6, also equal to 1/3. And finally, we divide it into 24 pieces. 8 are yellow. 8/24 is equal to 4/12, which is also equal to 2/6 and 1/3. Here's one circle divided into 3 pieces, and the yellow region is 1/3. The other circle is divided into 4 pieces, and the yellow region is 1/4. The picture shows pretty clearly that 1/3 is larger than 1/4. But if it wasn't clear, we could divide both circles into the same number of pieces, in this case 12, and now it's clear that 4/12 on the left is more 12s than the 3/12 on the right. So 4/12 is greater than 3/12, and therefore 1/3 is greater than 1/4. And that brings us to the equal fractions property. If the numerator and denominator of a fraction are both multiplied or divided by the same non-zero number, then the resulting fraction is equal to the original one. Or, if k does not equal 0, then a divided by b is equal to k times a divided by k times b, which is also equal to a divided by k divided by b divided by k. And let's look at 1/3 and 1/4 again, and see if we can figure out which one is larger without drawing pictures. We use the area at the bottom to show our work, so we write a 1/3 and a 1/4, and we apply the equal fractions property to multiply the 1/3 times 4/4 and the 1/4 times 3/3, giving us 4/12 and 3/12. And since 4/12 is larger than 3/12, 1/3 is greater than 1/4, and we write the greater than symbol up at the top. Notice we multiplied both the numerator and the denominator of the 1/3 by 4, which was the denominator of the second fraction. And we multiplied the numerator and denominator of the 1/4 by 3, which was, of course, the denominator of the first fraction. Let's do that again. We have 3/5 and 2/3. We multiplied the 3/5 by 3/3 and the 2/3 by 5/5, and we get 9/15 and 10/15. And since 10/15 is greater than 9/15, we know that 3/5 is less than 2/3, and we write the less than sign up at the top. Here's 7/12 and 2/3. Now in this one, we could multiply 3 times 12 and get 36, but we're not going to do that because 3 goes into 12. So we multiply the 7/12 by 1/1 and the 2/3 by 4/4, giving us 7/12 unchanged from its original representation, but the 2/3 is rewritten as 8/12. And since 8/12 is larger than 7/12, we know that 7/12 is less than 2/3, and we write the less than symbol up at the top. Here's 11/15 and 13/18. We could multiply 15 times 18 and get a pretty large number, but we're going to use a slightly smaller number. Our number is 90. And to get to 90, we'll multiply the 11/15 times 6/6 and the 13/18 by 5/5, giving us 66/90 and 65/90. So 66/90 is more than 65/90, so 11/15 is greater than 13/18. But the question you might have is, how did we know to pick 90 as the number we were after? Well, we did that by counting by 15s, and then counting by 18s until we found a match. And the first match in those two lists is 90. There's another way to do it. Multiply the 15 times the 18 and divide by their greatest common factor. 15 times 18 is 270. The greatest common factor is 3. 270 divided by 3 is 90. Another way to find the lowest common multiple of 15 and 18. Because it's the lowest common multiple that we're looking for when we're comparing these fractions. And now it's time to review several terms that have already been used in this lesson and a couple of other necessary terms that are involved with this topic. And we'll start with factor. A number to be multiplied is called a factor. Since 3 times 4 is equal to 12, we say that 3 and 4 are factors of 12. The counting numbers that are factors of 12 are 1, 2, 3, 4, 6, and 12. The counting numbers that are factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. The greatest common factor, or GCF, of a pair of counting numbers is the largest factor that is common to both numbers. So for 12 and 30, we write down our two lists, and we look at the largest number that is in both lists, which is 6. So the greatest common factor for 12 and 30 is 6. The lowest common multiple, or LCM, of a pair of counting numbers is the smallest counting number that both numbers in the pair are factors of. So now we count by 12s and we count by 30s, and we're looking for a match, the smallest match, because if you went on forever, there would be infinite matches. But the smallest match is 60. So the LCM of 12 and 30 is 60. A simple fraction is a fraction that has integers as both the numerator and denominator. A fraction in lowest terms is a simple fraction whose numerator and denominator have a greatest common factor of 1. A prime number is a counting number with exactly 2 counting number factors. A composite number is a counting number with more than 2 counting number factors. And that brings us to the fundamental theorem of arithmetic. Every counting number greater than 1 is a prime number or can be represented as a product of 2 or more prime numbers. This factoring can be done in exactly one way, except for the order of the factors. The representation of a number as the product of prime numbers is called the prime factorization of the number. So here are some examples. 6 is equal to 2 times 3. 10 is equal to 2 times 5. 30 is equal to 2 times 3 times 5. And 36 is equal to 2 times 2 times 3 times 3. And we also write prime factorizations with exponents, so 36 could also be written 2 squared times 3 squared. Here's 4/8, and we're going to write it in lowest terms. I believe we can do it in our heads. Both numbers are divisible by 4, so we do that and we get 1/2. We could also do it in steps. We could start by dividing them both by a common factor, 2. It's not the greatest common factor, but it gets us to 2/4. We divide both of these numbers by 2, and we still get that 4/8 is equal to 1/2 when it is written in lowest terms. Here's 10/35. If you know your times tables, you know to divide both these numbers by 5, and you get 2/7. But here's 56/84. I don't have my times tables memorized up this high, so I'm going to do this one in steps. They're both even, so I'll divide them both by 2, giving me 28/42. Now I can divide these by 2, but I also know they're both divisible by 7. So I do that, and I get 4/6. Now I have 4 and 6. They're both divisible by 2, giving me 2 and 3. And we can't divide anymore. The GCF between 2 and 3 is 1. So in lowest terms, 56/84 is 2/3. This lesson looked at the equal fractions property. Factors. The greatest common factor, or GCF. Lowest common multiple, or LCM, sometimes called least common multiple. Simple fractions. Lowest terms. Prime numbers. Composite numbers. Fundamental theorem of arithmetic, and prime factorization.